Reaction mechanisms are the processes by which reactions occur. In other words, what happens in getting from the reactant state to the product state? If we give you an analogy here with Legos, how does this become that? What gets hooked together first? Then what? Then what? That's what we're talking about with a reaction mechanism. Sometimes mechanisms are dependent on temperature. For a given reaction at one temperature, it might have a different mechanism if the temperature is warmer or colder. Elementary steps or elementary reactions are steps in which reactants turn into products in a single step. This is elementary, Watson. And before we talk more about elementary steps, let's define molecularity. A reaction's molecularity is defined by the number of particles that participate as reactants in an elementary step. A unimolecular reaction has one reactant. A bimolecular reaction has two. A termolecular reaction would have three, but these are incredibly rare. It is very rare that three particles would meet at exactly the right spot, in exactly the right orientation, in order to produce some kind of a change. We're not really even going to talk about termolecular reactions. Unimolecular and bimolecular is what we're going to limit ourselves to. Writing rate laws for elementary steps is very simple, and here's how you do it. In the middle you can see we have a series of what we are told is elementary steps. Wait a minute, Mr. B, I thought you said that termolecular reactions were really, really rare. Well, they are. They're incredibly rare. But I included them here so that you could see the pattern that emerges if you are told that you have an elementary step. For the first one, the rate law is written this way. Rate is equal to K times the concentration of A to the first power, and that's it. For the second one, the rate law is rate is equal to K times the concentration of A squared. For the third one, the rate law looks like that. Take a look at those rate laws and take a look at those elementary steps and see if you can see some kind of a correlation. Unless you are thinking with a bruised banana, you can see the correlation. Therefore, the rate law for the next one must look like that. And the rate law for the next one would look like that. And the rate law for the last one would look like that. In other words, if we know that here is an equation for an elementary reaction, then, and only then, we can write the rate law for that step based solely on the balanced equation. Let's summarize elementary reactions. A reaction's mechanism is the stepwise process the substances in a reaction go through in going from the reactant state to the product state. In an elementary step, or elementary reaction, there is only a one-step change between this state of affairs and that state of affairs. We can write the rate law for an elementary reaction from its balanced equation. We cannot write a rate law for an overall reaction from its balanced equation unless we are told that that equation is an elementary reaction.